1:15 a.m., July 11th, 2025. Multiple flashes light up the sky over the Moscow region. Drones, dozens of drones. They are carrying 60-kilogram warheads. Suddenly, they appear over the aircraft factories in Moscow. Russian air defenses fire several interceptor missiles, but they are unable to prevent the destruction. Everything is engulfed in flames. This is not a movie. This is the story of how drones broke through Moscow's defenses and destroyed critical Russian factories. It all started a few hours earlier.
The Ukrainian Strategic UAV Command convenes a planning meeting at 10 p.m.
Satellite images taken 2 days earlier showed 7 newly painted MiG-35 fuselages at the Lukhovitsy airfield and open-stock Pantsir missile containers at the Tula site. The Lukhovitsy MiG assembly area was marked as the primary target. The Tula Shipunov Design Bureau was the second focus, deemed critical due to its missile fuselage production lines. The Lukhovitsy target was 560 kilometers from the launch pad, while Tula was approximately 490 kilometers away. These data indicated the use of medium-class propeller-driven UAVs. The operation would involve the Bober, UJ-22 airborne, and single-shot Tu-141 Strij platforms. The Bober has a composite fuselage, a range of 850 kilometers, and a 40-kilogram shaped warhead. The UJ-22 airborne has a range of 800 kilometers and a 15-kilogram explosive warhead. The Tu-141 Strij has a range exceeding 1,000 kilometers and the capacity to carry over 60 kilograms of explosives. The Bober was suitable for low radar signature, the UJ-22 for widespread field logistics, and the Tu-141 for high-speed saturation. The intelligence officer marked the backup power lines with a red pen and converted the target coordinates into Delta Wave GPS format. The third series of Bober bodies were ready. The Ukrainian Strategic UAV Command's special unit loaded 32 kilograms of Kryzhetin T explosives onto 12 Bober fuselages, 4 UJ-22s with anti-personnel shrapnel, and 2 Tu-141s with 60 kilograms thermobaric warheads. Launch rails were set up in camouflaged areas in the Poltava Sumy rural region. Micro-UAV jammers were prepared as a pre-wave. GNSS jamming simulations confirmed that the Bober drones did not lose their INS terrain reference. On July 10th at 23:40, all units received final approval. The control room sounded the alarm, and the simultaneous industrial raid officially began.
The first 3, Bober took off from the launch rails, gliding 5 meters above the forest line.
2 UJ-22 selected the northern route, and 2 UJ-22 selected the Tula southern route. The Tu-141 Strij took off from the concrete runway at Mach 0.9. It was equipped with a radar reflector, enabling Russian Pantsir batteries to lock onto the high-speed target and miss the low-flying rotorcraft. Microjammer drones jammed the S-300 receivers on the Bryansk border. The Bobers advanced in the radar silent zone.
The Lukhovitsy route was loaded, and the Tula target was in the second file. The microwave jammer line closed when it passed the Stepnoy station. Russian air defenses had not yet opened fire. Altitude was lowered, and the final approach began.
With 400 kilometers behind them, the fuselages confirmed their fuel calculations, and the explosive fuses were activated. At 1:15, Bober 1 was over the Voronin factory compressor station, the main unit that supplied dry air to the MiG assembly line. The laser altimeter set the explosion at an altitude of 12 meters. At the same time, the Tu-141 entered the roofline of the administrative quality block of the Tula complex. The Pantsir S-1 battery fired its first missile. When the missile missed the Tu-141's decoy, the reaction window closed for the low-flying Bober missiles. UJ-22 pairs struck the transformer stations carrying security cameras around the facility. Russian radar consoles could not distinguish targets due to multiple signal saturation, and the image became distorted. In Lukhovitsy, the explosion destroyed the wall of the compressor building, halting the dry air supply. The engine assembly routine for the MiG-35 fuselages on the runway was suspended. In Tula, the thermobaric warhead of a Tu-141 shattered the administrative block and burned the electronic storage archive. Within seconds, A second explosion ignited the stored missile propellant. Smoke columns rose 500 meters, and the Panzer battery was silenced by the shockwave. The second Bober Yak-130 crashed into the side door of the test hangar. The spare wing roots caught fire.
The last Bober entered self-destruct mode and exploded at the edge of the asphalt runway, with drone debris scattered everywhere.
Ukrainian operators shut down the data link. The launch rails were dismantled and buried in the field's soil layer. Starlink terminals were shut down, and reports were sent to an encrypted archive. The official success announcement reached Kiev. Personnel and equipment losses were reported as 0. Russian radar patrols returned to normal scanning, but the fire images could not be concealed. The Ukrainian General Staff issued a brief statement referring to a planned attack on enemy defense industrial infrastructure, positioning the attack within the framework of the Army's previous deep strike doctrine. The alarm light at the Kremlin Situation Center turned red at 1:25. The Moscow-Ryazan air corridor was closed. Ukraine's deep drone raid targeting the Russian defense industry had destroyed 2 main facilities: the test and assembly hangars of the Voronin Aircraft Factory in Moscow Lukhovitsy, and the administrative and production block of the Shipunov Design Bureau in Tula. The targets chosen by Ukraine were not random. The Lukhovitsy facility, the primary target of the attack, houses one of Russia's most critical investment projects for its MiG-branded fighter jets. It is also known that Lukhovitsy houses the workshop for the prototype of the future single-engine light fighter aircraft. Under the Perspektivny Aviatsioni Complex General Nogo Motorostrenia project. This program is positioned to respond to the F-16 in the Russian VKS inventory. The workshop's inability to operate would delay the light fighter concept by at least 1 cycle. Here, MiG-29 and MiG-35 airframes are being integrated, avionics and hydraulic systems are being installed, and low-altitude test flights on the runway are conducted to complete factory certification. The same complex is the main maintenance and refurbishment hub for the Russian Air Force's rapidly aging MiG-31 interceptor fleet. Engine removal and replacement, radar modernization, and airframe fatigue testing are carried out in the long white hangar blocks adjacent to this runway. At the heart of the facility is a unit called the compressor station, which pumps up to 100,000 liters of dry, oil-free air per minute. This air is used both to pressurize the internal hydraulic lines and to create a moisture-free environment during the engine assembly phase. The official report has not yet been published, but if the collapse images are accurate, the shutdown of the compressor line could slow down the MiG-35 assembly pace for weeks, perhaps months. The MiG-31 fuselage repair program also cannot proceed without the arrival of new parts. The second target in the incident is the Shipunov Design Bureau, KBP, known as the Center for Body Electronics Integration of the Pantsir S-1 low-altitude air defense system. Here, missile tubes, multi-beam radar antennas, and target acquisition computers are mounted on the same chassis and undergo calibration. Additionally, some optoelectronic subcomponents of the Kornet EM anti-tank missiles and prototype bodies of the long-range Hermes K cruise missile are being tested in workshops adjacent to the same production line. At first glance, the burning of the administrative quality block may not seem like a disaster that would halt production, but this is also where the digital archive rooms are located, where parts tracking certificates and test reports are stored, and calibration bands are backed up. Even if backups of the archive databases are maintained, the quality approval cycle must be restarted if the physical laboratory is contaminated, which could delay the deployment of fresh Pantsir batteries to the front lines.
The damage to the Shipunov facility in Tula is twofold. The primary impact is the disruption of the maintenance and modernization cycle for existing Pantsir stocks, while the secondary impact is the delay in the release of the new batch of 57 E-6 missiles.
This missile line is typically prioritized for the air defense of the Black Sea Fleet's bases in Sevastopol and Novorossiysk. Thus, disruptions could create opportunities for Ukrainian UAV-USV combinations in the Black Sea. Kiev refers to such infrastructure strikes as strategic mechanics while pushing naval formations toward the waters off Crimea. The Ukrainian command targeted this delay precisely. The principle of low-cost, high-damage is crystallized here. A single compressor station costs $15 million, a press line segment costs $5 million, and an AR-07 infrared seeker production cabin costs $2 million. In other words, a drone worth tens of thousands of euros can cause millions in losses, and that's without spending anything on aircraft, pilots, or air defense fuel. Experts in the field offer two reasons why Russian air defenses were unable to prevent the attack.
The first factor is saturation. A large number of UAVs with different radar signatures are launched one after the other in the same flight corridor to force the defender's radar missile matching. When the radar operator prioritizes the large, fast-approaching aircraft, the low reflective propeller drones glide toward the target at low altitude. The second factor is the hybrid platform. A jet-powered Tu-141 is easy to detect for the Pantsir radar antenna, but it is a very fast target, and when the first two missiles are fired into empty space, the radar team does not have time to look down to low altitude before the battery reloads. Although the Russian Defense Ministry reported that 8 drones were shot down, the factory catching fire indicates that at least several vehicles managed to penetrate the defense and hit the roof.
The appeal of the drone strategy on the Ukrainian side is evident in the cost breakdown. According to open sources, the cost of a Bober's airframe and propulsion system is $20,000 to $30,000, with the total cost exceeding $40,000 to $50,000 when including the warhead. In contrast, a compressor station or Pantsir radar block test line are items costing millions of dollars. In other words, Kiev can impose repair bills on Russia that are difficult to bear at the cost of losing each kamikaze drone. Similar attacks in the past year have targeted oil depots, ammunition filling lines, and military air bases. The new element is the targeting of industrial arteries only 200 kilometers from Moscow. This move is intended to make the Russian public feel that the rear front is not secure. Establishing a psychological connection with the front is at least as important to Kyiv as physical destruction. Medium-term impact scenarios depend on Russia's response. If the MiG-35 assembly pace slows, the delivery schedule for new tactical jets will be pushed back, and Su-30/35 squadrons will have to fly more hours for air policing missions. More sorties mean faster engine wear and increased demand for spare parts. Disruptions in the Pantsir S-1 supply chain could weaken the low-altitude radar shield along the front line. This critical vulnerability could leave Russian ground forces exposed to long-range missiles like Storm Shadow or ATACMS, as well as kamikaze drones operating just behind the front lines. If Russian command relocates S-400 or S-350 batteries to the inner line to relieve pressure around the capital, radar missile density along the Ukrainian border will decrease. This could extend the response time of defenses against new drone attacks from the direction of Kharkiv or Sumy. These conclusions should be considered possible rather than definitive, as they depend on the official repair pace and whether backup lines are activated.
But military planners have already factored similar variables into their tables.
In short, while the Lukhovitsy and Tula raids remain officially confirmed with limited data, they highlight 3 key realities. First, relatively inexpensive unmanned systems can reach high-value targets just outside the capital. Second, a single faulty link in the defense industry infrastructure can create a domino effect in the aircraft and missile supply chain. And third, the classic concept of war, in which the rear is considered secure, is rapidly losing its validity in the age of low radar signature, GPS-guided kamikaze drones.
Ukraine is striving to turn these realities to its advantage by refining a small body, big impact strategy that takes cost-effectiveness into account.
Ultimately, Kyiv has struck Moscow's defense economic nerve centers again with relatively inexpensive drone platforms. Moreover, it did so simultaneously, slipping through radar blind spots over a wide range and disrupting civilian air traffic in the heart of Russia. The broken wall in Lukhovitsy, the melted press line in Shipunov, and the dominoes it has pushed over are having an impact on a much wider layer than just the frontline troops. The Russian chain of command will now have to divide the distribution of materials and ammunition in order to protect both the tank engines on the front line and the assembly spindles in the shadow of the capital at the same time. This gives Ukraine the ability to impose costly changes of decision with cheap bodies. The main idea of the strategy lies precisely here. Expensive things made of metal are time. Kiev is attacking time. Moscow is spending money to catch up with time. Thank you for choosing us. Don't forget to turn on notifications, leave a comment, and subscribe to our channel for more operation stories.